Hey everyone, welcome to the second part of the probability methods topic. We are going to cover topic 2 today, which is probability trees. Now, we've just done our first video on normal distribution, and if you haven't seen that, make sure you check it out. The link will be in the description. Now, for this topic, we are going to go through everything that you need to know in order to answer all the probability questions that you might get. Some questions might require some algebra or might be very difficult conceptually, but the hardest part is to read the information, go through all the points and all the information that they gave you, and create your probability tree correctly. Once you've done that, it becomes much, much easier. So let's dive in. First of all, before we talk about probability trees, we need to talk about outcomes and events. Now, what are outcomes, first of all? Now, outcomes are all the possible situations that can come up. So, for example, if you roll a die, numbers 1 all the way to 6 are your outcomes. That is all the things that can happen. If you're throwing a coin, you can have 2 outcomes, heads or tail. Now, if you have a combination of these outcomes, that will be considered an event. So, for example, the dice rolling 6 or 4, that is an event because it's a combination of outcomes. We could also have an event with just one outcome, but that's very boring. That could, for example, be you roll 1 die and you roll 3. Now, all of our outcomes together, we consider our sample space. Okay, now, just like we talked about, rolling a die, there's 6 different options for your outcomes, 1 all the way through to 6. Flipping a coin, tail, and head. Now, what could be an event here? An event could be rolling 3 and getting head with your coin flip. If we write down the probability of an event, our notation is here at the bottom, so P represents probability, and the brackets, that's kind of what we take the probability of. So we read this as the probability of event A happening. What are some of these probabilities? I assume that you know these already, so let's go through them. The probability of rolling a 1 is 1 out of 6. The probability of rolling a 2 is the same, 1 out of 6, because we have 6 options and we choose 1. The probability of 1 or 2 happening, well, that is 2 outcomes that we now have out of the 6, so the probability is 2 over 6, or simplified 1 over 3. The probability of 1 and 2 happening, that depends. In this situation, we're just rolling 1 die, so it can't happen. The probability is 0 in this case. If you're rolling 2 dice, there's going to be a different probability to that, but that we will do later. What about the probability of 1, 2, 3, and 4 happening? Again, that depends. If we just roll the 1 die, it's not going to happen, so the probability is 0. I just want to show you guys how the notation works so you guys can follow all of my working, and that you can adapt this notation to just go through the same structure, do the same every single question that you get, and overall have a much easier time in the exam. Cool, let's have a look at the next one. What are the outcomes in a tree? Where do we put them? So when we structure our tree, each branch will have the probability of 1. So the probabilities that we are going to have here have to add to 1, because every outcome that is possible, we're going to have to put in the probability tree. Here, for example, we have our branch and we have 2 options, head and tail, for a coin flip. Now we're going to write the outcome at the end of the line. We're going to make our lines, and at the end of the line, in between, we write our outcomes. The actual situation, the real life example of what is happening. We then write the probability of this respective outcome onto the line. So the probability of receiving head as your coin toss will be 0.5. On the other hand, the probability for tail is 0.5. You probably know this, but just make sure that you do. Here on this graph, we're going to see that the branches, each branch, every time they branch out, the probability has to add to 1. Here we have 0.6 and 0.4, 0.3 and 0.7. So I recommend every time when you have a probability tree question, you should go and create the full probability tree. Well, what do I consider the full probability tree? There's 4 parts. Let's have a look at the outcomes. That's the yellow here. All of the outcomes on the branches. Just like we just discussed, we create our lines and we write down what our situation is. And now if it's a big word, try to abbreviate it. You want as much space to keep it nice and clean so you know what you're doing when you're referring back to your probability tree. The second part is just like we discussed before, we want to fill in all the probabilities on the lines for the branches. So each of the lines, we want a number representing the probability of achieving that outcome. This is where normally most students stop and then they go to the next question because they think their probability tree is finished. And you can think that it is, but I highly recommend just for every single probability tree, continue with step 3 and step 4 until you are so confident that you're doing this in your sleep. First, we're going to write down the overall outcome after each line, after each part. So let's have a look at a probability tree. Here we are first tossing a coin, then we're rolling a die. So if we do the first event, we can have head or tail. So we have 2 options. Now in the next one, we have 6 different options for our outcomes, but we're going to consider an event. One event is that we roll a 6. The other event is we're going to combine all the other numbers, so we're not going to roll a 6. So let's have a look. Head and 6 will give us the outcome of getting head and a 6. If we follow head and not 6, well, no surprise, head and no 6. Tail and 6, tail and not a 6. Now, you will, after a while, get to know this very quickly. You will see this very easily, but I recommend that you do the extra 5 seconds to write this down, because when you look at the questions later, they are going to, the way that it's formulated is they're going to try and trick you. They're going to try and find, do you understand not just the probability, but also the concept? Do you understand what I'm asking? So they could, for example, be asking, where did we not roll a 6? And then all you have to do is you have to go through your outcomes, your overall outcomes, and check, did we roll a 6? Yes, no, yes, no, yes, no. And then we just tick, tick, tick the ones that we actually want. Now, the last part, and this is actually the more important one, I think, we should write down all the probabilities of the overall outcomes. So we already have all the probabilities in green on the tree, but we want to have the overall outcomes as probabilities. So we want to have the probability of the combination head and 6. So if we now look at this graph, in order to get to head and 6, we first have to go head and then 6. So that means we have to calculate a half times the 6, which is 1/12, and that is the outcomes probability. So let's do the computation slowly, one by one. So calculating the end probabilities require you to follow a path on the probability tree. And I always say, if you're walking on the tree, if you're going on the tree, you need to multiply the probabilities. Some probabilities are going to be added or subtracted. Some are going to be multiplied. So it's important that you remember, as soon as you're like on the tree, you're going a path, multiply the probabilities. So for probability head and not a 6, we multiply first going towards head, then to not a 6 which is 1/2 times 5/6. And you can put that in the calculator to simplify it as well if it needs to be 5/12. And if you're not confident leaving it as a fraction, by all means, put it in the calculator and make it a decimal. That's perfectly fine. Just remember, for probabilities, we expect 4 decimal places when you round your answer. So you want at least 4 decimal places when you're rounding. Now, at the end, you should check that all your probabilities in your column, in your final column, the probabilities at the end, add to 1. Well, why do you think they have to add to 1? Well, let's think. Probability of 1 means we cover every possible outcome. Well, if we are throwing a coin and a die, we only have 4 possibilities. Head and 6, head not 6, tail and 6, tail not 6. Nothing else can happen. So if any of those come up all together, they should claim 1 as the full probability. So once you've set up the complete table, the tree, it is much easier to actually just read off numbers, answer the questions. You will see that a lot of the times you're just going to spend time doing this tree, making sure everything is right and well, and then you're going to answer the questions and boom, here's my first answer, boom, there's my second. You just need to look at the tree and use your numbers. So if the question is asking you now, what's the probability of tail and no 6? Well, we just look what we have, tail and no 6. That is exactly that number there, boom, and we're done. Now, the hardest part creating this tree is to actually put it up, set it up. It can be very difficult, especially with the way that the wording of the question comes. And I can just recommend you read every sentence one by one very slowly. Read one sentence, try and understand what they're saying, then read the next one by one. There's a few things that will help you to structure your tree, but let's have a look at the order first. This will help us how to identify what we need to look for. So the order matters. So we cannot simply switch these two. We cannot switch these and these. Now this is a very easy probability tree. We have event A or event B happening in the first step with a probability that A happens and the probability that B happens. And then we can have A or B again with a possibly different probability. So in this case, the first branch must happen first. So whatever we have here, whatever we put here, this is what we get first. In our previous one, we were looking at throwing the coin. This is assumed that you throw the coin first at all times. Here it doesn't matter because of independence. We're not going to get too much into independence, but for majority of your probability trees, it is going to matter which way you're going to start. Now, there's one part that I have written up here, P of A/B. We say probability of A happening, given, that line means given we know B has already happened. That means something is information that we have. We have past information. So if we're looking at the probability of A given B, that means B has already happened. In this case, on the tree here, we have already walked here. We're currently sitting here. And what we want to know is the probability of A knowing that we're already at B, which gives us only one way, only this branch here to get to A. Yeah? So we call this conditional probability, and we will do more conditional probability, especially in the tables and probability part in the third part of this series. So let's talk about setting up your tree. This is one of the most important parts, and this will take you the most time in the probability tree question. So read carefully and spot conditional probabilities that they give you. These will help you identify which of the branches go first. So some of these keywords are going to be if. If I have eaten breakfast, what is the probability of going out for coffee? Yeah, that means I have already had breakfast. It's given information. Obviously, given, I mean, that's a pretty good giveaway. Given I had breakfast, what is the probability I'm going out? Yeah. Out of the students that have finished their exam, what is the probability they used a black pen? We're only looking at people that have already finished their exam. This is restricting where we're up to. A very similar one is from those, of those, or people that have finished the exam. You have to be very careful with the wording. So let's have a look at spotting some of these and see what they tell us. Let's do an example. A cafe owner realizes that 30% of the customers are over 65 years old. He's interested in comparing the milk type for customers over 65 years old and for customers under 65 to see if he can expect to make a difference between the coffees. Out of the customers that are younger, 55% prefer alternative dairy-free milk, whereas the customers over 65 years, the owner only notices a 24% preference for alternative milk. Now, pause the video and try it for yourself. What is the given information here? What could be the first path in your probability tree, and what's the second? Okay, I'm assuming you have actually tried this, so let's have a look at some of the wordings here. Are over 65 years old. That is our first part. And here we're only getting one piece of information, which kind of leads us to think this is the only thing that we are interested in here. That could potentially be our first outcome, our first line for the probability tree. But one of the facts that is much easier to recognize is these statements that we've just talked about. Out of the customers that are younger, well, this is looking only at customers that are younger. So that means in our probability tree, we have to already walk somewhere. We have to already go to younger customers, then somewhere else. So that's an indicator that our line before has to be younger customers. Now here we said 4 customers over 65 years old. Again, 4 was our keyword that we're looking only at customers 65 years or younger. Over. And now again, this means we first have to make a line with over 65 years before we can use the rest of the information in this sentence. So here we're going to set up our tree by having 65 and over and under 65. From those statements, we recognize that we first have to identify the age of the customer. Then we can talk about the preference of the milk. Also, the statement that was alone helped us confirm that this is how we want to set up our probability tree. Now let's look at some of the other statements in this example. Now we have identified, and that's the yellow part here, that 30% of customers are over 65% years old. So we are going to put this on the branch that is our probability of 65 plus. And you know, percentages means divide by 100. So 30 divided by 100 in the calculator if you're not sure, but this is 0.3. Let's have a look at the orange part. It says 55% prefer alternative milk. Well, let's have a look where that came from. That came from out of the customers that are younger. So we are going to go on the probability tree and we're going to go to where the younger customers are. And then we're going to check, well, this way is alternative milk that we're interested in here. So again, the probability here will be 0.55. Lastly, we're going to look at the green part, 24% preference for alternative milk. And that was again for the people that are 65 years older and older. So we first walk to 65 and then we check where we have alternative. Right, let's put all those numbers on there and let's check the rest. In order to fill up the rest of the probability tree, you need to remember the rule that each branch they add to 1. They will not give you any more information than they need to. So all of these blue paths now are really easy to calculate. It's always 1 minus the other. So 1 minus 0.3 will give us the red question mark, 1 minus 0.24, and 1 minus 0.55. Let's chuck those values out there, and we're basically done. Wait, this is what everyone does. They stop here. What do I recommend? I recommend that we continue writing with our third step. We want to have all of our outcomes at the end. Well, think about it. Pause the video if you have to. What is the outcome here? It's 65 and over and alternative milk. Yeah, go through each of them and make sure that you check that that you have all of them, that you write them all down. Now, just because it's getting a little bit small on space, I'm going to move my probabilities up there, but you are free to have them at the end, just like we had in that table before. So for the first pathway, 65 and over and alternative, that's the probability of 65 and alternative, is the pathway 0.3 and 0.24. And remember, if you're walking on the probability tree, you multiply the probabilities. Make sure that you are confident in setting up your tree all the way until the fourth phase. Now, once we have this, answering these questions become much, much easier. So let's have a look. There's just 2 questions up here. What is the probability of someone being under 65 years old and drinking dairy? So we just need to check. Under 65 is here. Drinking dairy is the normal milk, the dairy milk. So we just check this one here, and that was 0.315. What is the percentage a customer does not drink alternative milk? So we kind of need to have a look at our tree. So where do we have not drinking alternative milk? Well, this person drinks alternative milk. This person would drink alternative. So we have 2 options here. So the people that are 65 and older that drink normal milk, it says not alternative, so normal. And the people that are under 65 that drink normal. So there's 2 ways that we can actually classify these people. So what do we do in this situation? Now, if you're setting up the tree, remember at the end you should have all your probabilities. So this will be a 1-step answer for you. Now, if there are multiple ways in your probability tree that apply to the event that we're interested in, so not alternative, then we add the probabilities together. And when I say add, I'm talking about the end probabilities, the probabilities that we're calculating at the end. We're checking each of these outcomes and we're going to add them together. So let's have a look here. We have the way 65 and over and normal. So 0.3 times 0.76. And we're going to add that with the second pathway, which is 0.7 times 0.43. Awesome. And that was all on probability trees at the moment. Make sure that you go through the video again if you have to. Make sure you have all your notes down. Do some practice examples if you can. And then I will see you in the third part of this topic for probability tables.